So, good morning to everybody. So, today my topic is nomenclature of organic compounds. So, nomenclature of organic compounds means how to name organic compounds. So, before we discuss about naming, so let's have a brief description about organic chemistry. So, organic chemistry is defined as the chemistry of carbon compounds containing usually hydrogen and one more additional elements like oxygen, nitrogen, sulfur, halogen and phosphorus. So, organic chemistry is the chemistry of organic compounds. So, organic compounds contain carbon and mainly carbon and one of elements from hydrogen, oxygen, nitrogen, sulfur, halogen, phosphorus, etc. Further, organic compounds made up of only carbon and hydrogen atoms are called hydrocarbons. So, organic chemistry is the chemistry of the hydrocarbons and their derivatives. Organic chemistry is the study of carbon compounds. The study of carbon compounds, organic chemistry focuses on any compounds with carbon. Organic compounds can range from the simple carbon dioxide or methane to complex molecules like proteins that may weigh for over 1 lakh daltons. Organic chemistry is a separate branch of chemistry. It is studied as a separate branch of chemistry because of the following reasons. Composition. So, first of all, composition. Organic compounds are made up of a few elements such as carbon, hydrogen, nitrogen, oxygen, halogen, sulfur, phosphorus, etc., while inorganic compounds are made up of most of the elements in the periodic table. So, in spite of a few elements which are composed of organic compounds, the number of organic compounds is very large as compared to inorganic compounds. The next is number, though the number of constituting elements in organic compound is very less as compared with inorganic compounds, but the compounds they form are many times more. So, in spite of being that only few elements are being used in the organic compounds, but all the elements are used in inorganic compounds. The number of organic compound is much more than inorganic compounds. Linkage. Organic compounds generally contain covalent linkage, whereas inorganic compounds contain mostly ionic linkage. Complex structure. Most of the organic compounds such as proteins, vitamins and carbohydrates etc. have complex structure and high molecular masses. Solubility. Due to their covalent character, these are soluble in non-polar solvents. Combustible. Due to the presence of carbon in them, these are combustible in nature in contrast to the non-combustible nature of inorganic compounds. Linkages. Organic compounds are generally contain covalent linkages, whereas inorganic compounds contain mostly ionic linkages. So, covalent compounds have complex structures and they are soluble in non-polar solvents. Covalent compounds, due to presence of carbon in them, they are combustible nature in contrast to non-combustible nature of inorganic compounds. Melting and boiling points. Due to their covalent nature, their melting and boiling point is low and these are volatile. Electrical conductivity. Covalent compounds are poor conductor of electricity, same due to the covalent bond and absence of charged ion. Inorganic compounds have charged ion, so they are electrical conducting in nature. Homologous series. Organic compounds have been classified into a number of families called homologous series. Isomerism. Organic compounds show isomerism. One compound having the same molecular form but different physical and chemical property are isomer. So, organic compounds show isomerism property, isomer property. Sources. Organic compounds are mostly obtained from living organisms, that is from animals and vegetable kingdoms, whereas inorganic compounds we obtain from rocks, soils etc. Stability. Organic compounds are usually less stable than inorganic compounds towards heat. Analytical method. The various techniques used such as steam distillation, vacuum distillation, solvent extraction and chromatography etc., which are employed for the purification and identification of organic compounds, are less common in analysis of inorganic compounds. So, let's we discuss about tetravalency of carbon, that is carbon form 4 bonds with another elements. So, the basic configuration of carbon is 1s2, 2s2, 2px1, 2py1 and the 2pz1 is empty. So, in 4 orbitals of carbon, 1s orbital has 2 electrons, 2s orbital has 2 electrons, 2px orbital has 1 electron and 2py orbital has 1 electron. The excited state configuration is written below. In excited state configuration, 1 electron from 2s orbital is excited to is promoted from 2s orbital to 2pz orbital. So, this is the excited configuration of carbon. Tetravalency of carbon. The electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1, 2pz1, 2pz0. Carbon has 4 electrons in the valence shells and thus needs 4 more electrons to complete its octet. So, here in configuration 1s2 orbital 1s2 electrons are in ground state. So, in valence shell we have 4 electrons, 2 electrons in 2s orbital that are paired, they promoted 1 electron from 2s orbital is promoted to 2pz electron, 2pz orbital. So, all of the 4 orbitals in the valence shell have 1 electron. So, therefore, carbon is tetravalent. Therefore, it is very difficult for carbon to either gain or lose 4 electrons to achieve the nearest noble gas configuration. So, carbon always combine with almost with atoms by mutual sharing of electrons and thus forms covalent bond. So, this is the tetravalency of carbon, which shows the 4 bonds of carbon with hydrogen. Catenation property of carbon. The self-linking property of an element as a result of which it forms bonds with atoms of the same element is called catenation. Carbon shows maximum catenation amongst all the elements in its group in the periodic table. This is due to the larger strength of carbon bond as compared to that of other atoms. So, the self-linking property of any element as a result of which it forms bond with atoms of the same element is called catenation. So, carbon has the maximum catenation, shows maximum catenation amongst all the elements. Classification of hydrocarbons or compounds. This is the table shows the classification of hydrocarbon compounds. So, hydrocompounds which are formed from carbon and hydrogen atoms, they are divided into 2 types, open chain and closed chain. So, open chain are also called acyclic compound, closed chain are called cyclic compound because they form cycles. Open chains contain aliphatic hydrocarbons. So, open chain compounds are further divided into 2 types, saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbons are those hydrocarbons which have only single bond between carbon to carbon. In unsaturated hydrocarbons, there are multiple bonds in carbon. It may be double bond or triple bond. They can be saturated by addition of hydrogen. So, unsaturated hydrocarbon are those which contain only single bond between carbon, and in unsaturated hydrocarbon at least there is one double or triple bond in the carbons. So, closed chain are divided into homocyclic and heterocyclic. So, homocyclic are further classified into alicyclic and aromatic hydrocarbons. Alicyclic hydrocarbons are those which form cycle, but they do not have aromatic ring in them. So, aromatic compounds are those which have at least one aromatic ring, that is benzene ring in them. So, another property is functional group. Hydrocarbon have functional group. So, functional group is that group which may be defined as an atom or group of atoms present in a molecule which largely determine its chemical properties. So, due to this functional group, the property of a hydrocarbon is changed. Functional groups are parts of molecules that result in characteristic features. About 100 functional groups exist. For example, the simplest group is hydrocarbon, made up of only carbon and hydrogen. Functional groups, specific groups of atoms that make up part of a larger molecule and have particular chemical properties, shape, polarity, reactivity and solubility. So, now we discuss about naming hydrocarbons, that is nomenclature. So, nomenclature nomenclature means how to name hydrocarbons. Nomenclature means the system of naming compounds based on certain guidelines. There are two types of systems prevailing. So, first of all is common or trivial system, and the second is IUPAC system. The common or trivial system is that system in which the common name or the popular names are taken as such. In the earlier stages of the growth of organic chemistry, the compounds were usually named after the sources from which they were prepared. For example, acetic acid derived its name from acetum. So, Latin acetum means vinegar, and it is present in vinegar, so to whom we call sirka. So, and the formic acid derived its name from formica, that is red ants. So, formica in Latin is red ants. So, as formic acid is obtained from red ants, so these are called formic acid. So, as acetic acid derived its name from acetum, formic acid derived its name from formica, that is red ants. Alcohol was named wood spirit since it could be obtained by distillation of wood. In some cases, the compounds were named without any systematic basis. But the IUPAC system, this is the modern and the more systematic way of naming. So, in this system, modern system based upon the agreement reached on International Union of Pure and Applied Chemistry in year 1959. In this system, the named are allotted according to their structure of compound and different according to their functional groups. So, the IUPAC system, IUPAC means International Union of Pure and Applied Chemistry, whose head office is in Geneva. So, at first of all in 1959, modern system based on the agreement reached at International Union of Pure and Applied Chemistry in the year 1959. These rules were modified and published in 1979 and again revised in 1993. The most important feature of IUP system is that a given compound can be assigned only the one name. At the same time, A given name can be clearly direct in writing of one and only one molecular structure. That is, only one name is to be given of a compound, and at the same time a given name can be clearly direct in writing of one and only one molecular structure. That is, from one name we can derive only one structure. So, IUPAC system is the most widely used system of nomenclature in organic chemistry. The IUPAC name of any compound essentially consists of three parts. So, that is word root, suffix, prefix. So, prefix means that is fixed before the word root, prefix, and suffix that is fixed after the word root, suffix, to whom we call agetar, pishetar. So, there are two types of system of naming of organic compounds. First of all is common system and second is IUPAC system. So, common names are derived from the popular name of that compounds, popular names of that region, and IUPAC systems are systematic way of naming the organic compound, and this is the, and there is one and exact name of that compound. This is the most precise and perfect method of naming. So, in IUPAC system, in IUPAC system the name has three parts. First is word root, second suffix, and third is prefix. So, word root is the basic unit of IUPAC name. It denotes the number of carbon atoms present in the parent chain, that is the longest chain of carbon atoms including the functional group and the multiple bonds of the organic complex or organic molecules. So, word root means how many carbon atoms are there in a chain. So, first of all we take the longest chain, longest continuous chain. So, the stress should be given in the longest continuous chain, that is there may be more than one longest continuous chain. So, we will have to choose the best, longest and continuous, that is whose length is more, which has more carbon numbers in them. So, according to the number of carbon atoms we assign them the word root. For example, if the carbon number is 1, we assign it meth. If carbon numbers are 2, we assign it eth, and if the carbon number is 3, we assign it prop. For 4 carbon atoms we assign but, for 5 carbon atom we assign pent, for 6 carbon atom we assign hex, for 7 we assign the carbon number, for 7 carbon number we assign name hept, for 8 carbon number the name is oct, for 9 carbon number the word root is non, for 10 carbon number the word root is dec, for 11 undec, for 12 dodec. Okay. So, according to the number of carbon atoms in chain, the word root is given to that name. So, for example, if the carbon number in longest chain is 8, so the word root is, what is the word root? The word root is oct. So, longest carbon chain is taken for the word root, longest and continuous. Suffix attached at the end of the word root. Suffix is that part of the name that is attached at the end of the word root. So, before word root the part of the name is prefix, and after word root the part of the name is suffix. So, there are two types of suffixes, primary suffix and secondary suffix. So, primary suffix is, it indicates whether the carbon chain is saturated or unsaturated. The three basic primary suffixes are. So, if the carbon chain has only one only single bond in them, that is saturated hydrocarbons. So, for saturated hydrocarbons the primary suffix is ane, for example, methane, ethane, butane, propane. and if the carbon chain in carbon chain any two carbons has one double bond in them, then the suffix is primary suffix is ene, ene, that is attached after the word root. For example, ethene, propene, and the general name is alkene. For general name of saturated hydrocarbons is alkane. General name of unsaturated hydrocarbon with one double bond is alkene. The unsaturated hydrocarbon with at least one triple bond is yne, 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 and the general name is alkyne. General name of that compounds are alkyne. So, for example, if there is a triple bond in carbon chain, so the name is if and the carbon numbers are 4 and one triple bond, so the name is butane. Again, if there are two or more triple bond, then diene is written after the word root, and the number of the triple bonds also should be mentioned. When the primary suffix is followed by a secondary suffix beginning with a vowel a, e, I, o, u, final e of the primary suffix is deleted. When the primary suffix is followed by a secondary suffix, so these ane, ene, yne are the primary suffixes. So, only 3 types of primary suffixes are there according to their saturation of the carbon chain. Secondary suffix is added after the primary suffix to indicate the nature of the functional group present in the molecule. Primary suffix is according to the saturation of the carbon chain and secondary suffix is according to the functional group of the carbon chain. If there is functional group located, the name of the functional group is added after the primary suffix, and that is a secondary suffix. The position number or locant of the secondary suffix functional group is placed immediately before the secondary suffix. So, different types of secondary suffixes are according to functional groups. So, if the functional group is alcohols, that is OH, the secondary suffix is ol, small o and small l. Thioalcohol, SH, secondary suffix is thiol. Aldehyde, and secondary suffix is Al. Ketone, secondary suffix is on, CO. Carboxylic acid, COOH, secondary suffix is oic acid. Acid amide, secondary suffix is amide. Amine, secondary suffix is amine. NH2 is functional group and the secondary suffix is amine. Cyanide, secondary suffix is nitrile, the functional group is CN. Nitro, NO2, and the secondary suffix is nitro. So, there are different types of functional groups and their secondary suffixes. So, according to the functional group, we assign it we assign the name with special secondary suffix, and the name till now is word root plus primary suffix and secondary suffix. If the secondary suffix is present, then we will add the name of the secondary suffix after the primary suffix, but if the secondary suffix is not present, then that should not be added. We will not add that secondary suffix. The name should be stopped at primary suffix. So, another part of name is prefix. It is the part of the IUPAC name which is written before the word root. So, before word root we write prefix, prefix. So, there are 2 types of prefixes. Primary prefix, cyclo is used immediately before the word root in case of alicyclic compound only. If this prefix is not written, this means that its compound is open chain or acyclic. That is, primary suffix is used only when the compound is cyclic. Cyclopropane, cyclobutane, etc. That is, usually secondary prefix is added and primary prefix is added only when the compound is cyclic. Secondary prefix is added before the word root or before the primary prefix in case of carbocyclic or alicyclic compounds in alphabetical order to denote the side chain or substituent groups apart from alkyl group. Some other groups like fluoro, chloro, bromo, iodo and nitro are always treated as substituent groups. So, let us remind again. So, there are two types of prefix, primary and secondary. Primary prefix is used for only cyclic compound. Secondary prefix is used for certain types of functional groups like halogens, fluoro, chloro, bromo, iodo. Or any substituents attached to the ring, attached to the chain. The complete name is prefix plus word root plus suffix, and prefix are of two types, secondary prefix and primary prefixes. So, and after word root there are two types of suffixes, primary suffix and secondary suffix. So, the complete name is secondary prefix, primary prefix plus word root plus primary suffix plus secondary suffix. So, example showing naming of organic compounds. So, this is the example. So, in this compound, so at first of all we will take the longest carbon continuous carbon chain. The longest continuous carbon chain is, how many numbers are there in longest continuous carbon chain? So, there are 5. There are 5 numbers. So, there are 4 numbers and the one CH2 group is so the longest carbon chain is starts from CH2 of OH group, OH CH2 C CH CH2. Okay. So, the longest chain is made up of 4 carbons. So, and the functional group are OH, that is alcohol. So, in carbon chain the substituent attached are methyl and chloro. So, these are the substituents, methyl and chloro. So, the name of the compound written is 2-chloro 3-methyl but 2-ene 1-ol. So, the ene is primary suffix and ol is secondary suffix, ol for hydroxy group, that is alcohol group, ol is secondary suffix, ene is primary suffix, but is word root and 3-methyl and 2-chloro are the prefixes. If we will have to write primary prefix also, then the chain should be closed. So, this is the name of a organic compound. Nomenclature of different classes of organic compounds. That is how to name different classes of organic compound. Alkanes. Alkanes contain only single bond. So, before discussing about the names of different types of compounds, let us remind about the IUPAC name. The rules for IUPAC names are much more than described, but according to the specified syllabus of the first semester, the topic is design. So, IUPAC names have three parts: prefix, word root and suffix. Prefix are two types, primary and secondary, and suffixes are also two types, primary and secondary. So, the complete name is secondary prefix, primary prefix, word root, primary suffix and secondary suffix. So, nomenclature of different class of organic compound. So, first of all is alkane. Alkane contain only single bonds.